Hi everyone, my name is Richards and I will present our joint work with Ugne Kwimiene on multiview concept bottleneck models for diagnosing pediatric appendicitis. Interpretability is an essential ML model design principle that can be useful for developing better decision support systems. Concept bottleneck models, or CBMs, are one approach to interpretable classification. The inputs are mapped to the human understandable high-level concepts, which are then used to predict the final target variable. In this work, we will extend the vanilla CBMs to the multi-view setting to be able to handle multiple and varying numbers of views per data point. We'll also apply our model to the ultrasound images from pediatric patients with suspected appendicitis. Let us first, as a motivation, consider a few characteristics of a typical multi-view medical imaging datasets. Oftentimes, the views that we observe are homogeneous. They are very visually similar and contain a lot of shared information. At the same time, often the views may be loosely ordered, for example, based on their acquisition time. Last but not least, not all clinically relevant concepts are identifiable from all of the views. Based on these considerations, we have extended the vanilla CBMs to the multi-view classification setting. The schematic summary of our model is depicted in this slide. First, the views of the input are mapped to the view-specific representations using a shared encoder network. Then these view-specific representations are aggregated via a fusion function, for example, the arithmetic mean or LSTM. The aggregated features are then used to predict the concepts which are given to the model at the training time as a form of auxiliary supervision. And last but not least, we predict the target variable solely based on the concept predictions. Like the vanilla CBMs, our model is actually intervenable. In other words, a user may choose to edit the concept predictions at the test time in order to affect the output of the model. So the model allows for human model interaction in real time. We have applied MVCBM to a dataset of 275 pediatric patients admitted to the tertiary care hospital in Germany. The dataset consisted of abdominal ultrasound images alongside tabular data, including physical examination, laboratory test results, and manually extracted ultrasonographic findings. The final task was to predict the patient's diagnosis, appendicitis versus no appendicitis. Let us have a look at the results. The table in this slide depicts the results for predicting the diagnosis for the multiple models. Looking at the ResNet 18-based classifier with the late fusion of the views, we can see that in principle, we can predict the target variable based on the ultrasound images. On the other hand, if we utilize the hand-extracted ultrasonographic findings and train a multi-layer perceptron, we almost achieve an OROC of 90%. The MVCBM model falls somewhere in between. It performs significantly better than a ResNet 18 model with the late fusion, but does not quite achieve the performance of an MLP trained on the hand-extracted ultrasonographic features. At the same time, our MVCBM model is intervenable. In other words, replacing the concept predictions with their ground truth values actually significantly improves the performance on the test set. In summary, in this work, we have extended the concept-based classification to the multi-view setting to be able to handle multiple and varying numbers of views. Our model is a competitive alternative to black boxes and offers real-time human model interaction. Last but not least, we have also demonstrated that ultrasound imaging is a very promising modality for the computer-aided diagnosis of appendicitis. Thank you very much for your attention, and we look forward to seeing you at the poster session.